Hey guys, Joe here, and welcome to lecture 4.2 in module 3 for RAD104. And so what we're going to do here in this lecture is we're going to start talking a little bit about shielding patients. All right, so patient shielding, and as I've mentioned, things are changing rapidly at Beverly Hospital, where they're kind of going away from patient shielding. Is it that necessary? And I have to say that one thing that I've noticed since I've only done one shift since COVID-19, but I did have to shield a mother holding a child, and she was not happy to wear that shield. I think shielding is now looked at more of as another thing that's contaminated or dirty, and she didn't really want the shielding. But I felt compelled that she should wear it just because that's how I was taught. So anyway, she wore it, but you could tell it's more people are concerned of how dirty it is rather than the radiation protection at this point. So some things to remember with shielding is, again, we're never dealing with a whole body dose, so that helps with patient dose. And the other nice thing with diagnostic x-ray is that we are collimating to just a specific area of the body. And collimation is good in so many aspects. The only reason why collimation might be a problem is if you collimate too much and you cut off anatomy. Yes, that's a problem. But collimation, proper collimation, gives a patient less dose. It makes a better detailed image, so you're going to have better spatial resolution. You're going to get better penetration of the body part. It's going to lower your exposure index. So collimation has so many good aspects to it. And if we collimate correctly, we're not going to have that much scatter either. So another reason why collimation is great, and it reduces the need for shielding. Now the book goes into talking about patient shielding with regards to the eye, patient's breasts, and the gonads. Of course, we're always shielding gonads. One thing that you may have been taught when you started x-raying is that if you are doing an abdomen and you're doing kind of two halves, one on the bottom, one on the top, if you're doing the one on the bottom, it's not a bad idea to shield the breast tissue. Again, we don't want to, the breast tissue is fairly radiosensitive, not so much as the gonads, but it's something that we tend to try to protect if we can. We don't want to have any type of radiation lead to a breast cancer. So shielding the breast is always a good idea if you can do it. As far as shielding the lens of the eye, we really don't have too many opportunities where we're going to give somebody a pair of goggles in order to protect their eyes. So the book mentions it, I mentioned it, but I don't see that being practiced very regularly at all. The book also talks about different kinds of shielding, and we're really more used to wearing or using a contact shield, which is just that flat, small, rectangular blanket-like shield that you can drape over somebody. But there is something called a shadow shield, and I do see questions on the registry exam about the shadow shield, and there is a picture in your book, and I have it on the next slide here. Let me move my picture. So this is a shadow shield, and it attaches to the collimator up by the tube, and then it casts a shadow over wherever you want to point it. So this is a piece of lead, and that lead is absorbing any x-ray, so whatever is in the shadow of that shield will not have exposure to it. So this is kind of a nice way of not touching the patient and shielding them at the same time. So like any shield though, if it's improperly placed, you're going to end up with the shield in the image, which may not be suitable or recommended, but that is a shadow shield. You should know what it is. These are contact shields. I think this is something that I remember seeing. I would never ever use this. There used to be undergarments. There used to be for male patients a pair of underwear, and you would stick this shield. This is lead lined, like a rubbery shield for the penis, and this is you would a guy would put his stuff inside here, and that would protect him. Like I said, I've never seen that used. I've never seen it worn, and but you should probably at least know about it or what it is or what it used to be. I don't know of anybody who uses that. But these are the contact shields that we're used to. They're just draped over the patient. So this person is going to be getting a hip. The breasts are shielded. The opposite hip is shielded, and they're probably going to have this x-ray here. So contact shield, shadow shield, you should know what those are. If you have any questions, let me know. All right, I'm going to jump now to radiation monitors. And we did talk about radiation monitors earlier. We're going to find a few of the things that I'm going to talk about in this little Lecture 4 series. We've already gone over, but it is all under radiation protection. It's a really good thing to know. It's what sets us apart. It's what makes us an important part of the healthcare field, that we are experts in radiation and radiation protection. So therefore, I'm going to give you some stuff again. So let's talk about these radiation monitors. So I'm going to talk about 3 different kinds of radiation badges. The first kind is the kind that we're currently using now for students, and it's what everyone uses at clinical. If you're employed at Beverly or Salem Hospital, you're using an optically stimulated luminescence badge. The big name for this one is going to be Landauer or Luxel. I think Luxel is actually I'm not sure what Luxel is, but Landauer is the company that reads these badges for us. I don't know if Luxel is the manufacturer of these actual badges, but optically stimulated luminescence, these badges are made out of something called aluminum oxide. Okay, they work similar to a CR plate that you would find in or the old way of taking X-ray that takes X-ray energy. Those crystals, those aluminum oxide crystals, absorb the photon, absorb the energy of the X-ray, and then we're able to release that in the measurement of light. We can measure the brightness of that light. The brighter the light coming from these badges, the greater the exposure. They're nice because these badges are nice and hardy. They're hard to break. They don't deal with pressure or heat or light. You can put them through the washing machine without affecting the badge readings. They're really a good thing, and they're very, very radio sensitive, and they can read as little as 10 microgray, which is just a tiny bit. It's not a lot of X-ray at all. So they're very, very sensitive, and they are the badge of choice as far as I'm concerned, working anywhere around radiation. All right, the next dosimeter you should be aware of is a TLD, or a thermoluminescent dosimeter. This comes in a powder form. It's lithium fluoride crystals. We're able to compact that into like a tablet form. We can use it as a powder, but you can see you can make it into different shapes depending on what type of monitor or badge that you're using. So this might be more of like worn at the wrist. They might be able to make a ring similar to that we see for nuclear medicine. But TLDs, almost the same thing. These crystals will absorb the radiation energy, and to expose that energy, we expose the dosimeter to a heat source. That heat source causes light. That light is then measured. The amount of light reflects the amount of radiation dose that crystal received, and so therefore we're able to determine a dose. So again, it can be as low as 50 microgray, which is great. I thought this was kind of strange. If the way you release this light is through heat, yet the book claims that it is unaffected by heat. So I don't know if it has to be hot enough. So in other words, if you left a TLD in your car on a summer day, would that affect the reading of the badge? According to your book, no. So, but I thought that was interesting. So unaffected by heat, light, or humidity. So these are pretty hardy dosimeters, and they are used quite a bit. So we're going to learn a little bit more about them as we go forward. We will soon see that TLDs are used for measuring entrance skin dose, which we'll talk about in a little bit, and something that I know there are different entrance skin dose charts hanging up by all the rooms in Beverly, and so we're going to learn more about that, but TLDs play a part in that as well. So anyway, next badge. All right, film badges. So these are the old school badges that would use an actual piece of X-ray film, and they would be put inside this little clamshell, and they would be the piece of film is sandwiched in between these two parts here. So you would squeeze this together and click it shut. So you would have film inside here, and you can see that there are these little circles, and these circles are covered. This one here would be aluminum. This would be copper. There may be one that's just simple plastic. And so these filters help determine how strong the X-ray was in order to reach the film. So the strongest filter may be copper, and so if X-ray was able to penetrate the copper filter and affect the film underneath, then that must have been a fairly strong dose of radiation. And so they would use those filters to determine the amount of dose and the energy behind it. Now, film badges are very cheap, but they're not very good. They're not very resistant to heat or light. If this thing opened up with the film inside of it, the film would be exposed. It would be no good. You have just lost all of your badge readings. Certainly, you can't put these things through the washing machine. That would be a bad thing. They're not quite as radio sensitive, so they're only as good as, or as low. They can detect radiation as low as 100 microgray, which isn't as good as the TDLs or the OSLs. So, you can only use it for one reading, then you have to send it back. They will switch the film inside and send it back to you. So you don't see these very often. We don't use them anymore. We used to use them because of how cheap they were, but the OSLs are now becoming just as cheap. So I think you're going to start to see these go away. But that's a film badge. All right, guys, and with that, I'm going to wrap up this video. So if you have any questions about film badges or shielding or anything like that, shoot me an email. So if not, I'll see you at the next video. Bye.